Welcome back to part 2 of getting started with Python. In the last video, we got set up with Anaconda and spent our time in Spyder where we loaded a program, ran it, and made a change. This time, we're looking at another tool that comes with Anaconda, Jupyter Notebook. It's a different way of working with Python, and it's worth knowing both. They are each better at different things. So what is a notebook? In Spyder, we had a script, a plain text file of code that runs top to bottom all at once, with the output showing up in a separate console panel. A notebook is different. It's a single document that holds your code, your written notes, and your results all together in one place. The code is broken into chunks called cells, and you run them one cell at each time. And when you do, the output appears right underneath the cell inside the document. That makes notebooks great for working through a problem step by step, or for anything you want to hand to someone else and have it explain itself. You'll see them a lot in data analysis and teaching material for exactly that reason. So launching Jupyter from the command line, let's open it up. Same as last time, we will be using Anaconda prompt rather than clicking through Navigator. So Anaconda prompt. Before we launch the notebook, one useful trick: if you start Jupyter from inside the folder you want to be working in, it'll open right there and save you some clicking. So let's change to our project folder first. So go into Documents and then Python. Now let's launch Jupyter Notebook. So type out Jupyter space notebook. So a couple of things just happened. Jupyter started up and it opened a tab in your web browser. That's normal. Jupyter runs in the browser even though everything is happening locally on your machine. And notice how this terminal window is still running, filling up with text. That window is the engine running Jupyter Notebook behind the scenes. If you close it, Jupyter stops working. We'll come back to it at the very end to learn how to shut things down properly. This first screen is a file browser. It's showing the contents of the folder we started Jupyter in. We can see the two files we used in our last video, which is circledemo.py, the script file, and the data file, radii.txt, along with a notebook that I've prepared for us today. Once again, we're keeping everything in the same folder. The script, the notebook, the data, they all stay here together. Python looks for radii.txt right where the notebook is, so you don't have to spell out the full path. Getting into that habit early will save you a lot of headaches down the line. Also notice how the notebook has a different extension, .ipynb, rather than the .py we saw in Spyder. That's the notebook format. It stores your code, your notes, and your saved output all in one file. So let's open it. So here's our notebook. Let me point out the pieces before we run anything. Up top, there's a toolbar with save, add a cell, cut, copy, and paste, and then run cells. There's also a drop down here that shows the type of cell the selected cell is, which we'll use in a moment. Now the document is itself made of cells, and there are two kinds here. This one is a text cell. Jupyter calls these markdown cells. It's formatted writing, headings and explanations and notes to yourself. It isn't code and it doesn't do anything when you run it except display nicely. And this one is a code cell. You can tell them apart by the shading and by the square bracket label sitting to the left. That's real Python, and that's what actually runs. So the whole document kind of alternates. It's a bit of explanation, the code it's describing, and then the next bit of explanation. That's the notebook style. The writing and the code exist next to each other. So let's run a cell. You can run a cell by selecting and pressing Shift Enter together, that runs the cell and moves you down to the next one. So watch the label on the left. It was empty and now it says 1. That number tells you the order the cells were run in. This was the first thing to run. That's more useful than it sounds, and we'll come back to why in a little bit. That cell didn't produce any output because all it did was load in our libraries. Let's do the next one. So there you have it, the list of radii printed right underneath the cell that produces it. This is a big difference from Spyder. The output isn't off in a separate console. It's sitting right there in line in the document. So let's keep going. So we'll print the areas. So that's printing the areas and then plot the results. And then there's our plot, embedded right in the notebook, the same figure that we saw in Spyder's plots pane last video. But here it shows up in the document itself. Now let's look at the whole thing from the top. So there's some explanation, the code, and then the resulting output, explanation, code, and then the output. And then it reads like a document that happens to run code. One thing that's super important about notebooks is the kernel. Behind every notebook, there's something called a kernel, which is basically the Python process actually doing the work. And it remembers everything you've done in this session. So every variable, every import. That's handy, but it has a catch. Cells run in whatever order you run them in, not necessarily top to bottom. So it's possible to get a notebook into a confusing state, so running things out of order or deleting a cell whose variables are still in memory. Those numbers we saw on the side here are a record of what actually happened. If they don't read 1, 2, 3, 4 down the page, you've run things out of order at some point. The fix is simple, and it's a good habit whenever things feel off. Restart the kernel and run everything again from the top. So we'll go into kernel, hit restart kernel, and then we'll hit run all cells. And there you have it. Clean slate, everything run in order, and now you know the notebook works start to finish. It's worth doing that before you share a notebook with anybody else. So let's edit and rerun a cell, the same change that we did in the previous video. We'll switch from area to circumference. So we'll go to where the area is being calculated and go from pi r square to 2 times pi times r. So then we'll do shift enter, and then now it's printing out circumference. So notice how we only reran that one cell. We didn't have to run the whole file again, like we would with a script. That's the other thing about notebooks. You can change one piece and then immediately see the output. But now we've got a situation I just warned you about. The plot below is still showing area because we haven't rerun it. So we're going to go down and then run it. And now it has a linear relationship, which is the circumference. If you want the label to be honest, we'll just quickly change it to circumference and then circumference. So yeah, now that's an updated plot. Let's also add a note of our own so that we know how that works and what's changed in the notebook. By default, a new cell is a code cell. To make it a text cell, we want to change its type in the drop-down menu, go to Markdown, and then now it is a Markdown cell. So let's type something. I'm going to say notes change from area to circumference. So notice these two hash marks. That's just to make that line a heading. So that's what Markdown does. That's a Markdown syntax. Now we'll run it the same way. So shift enter, and there you go. So now it says notes. we change the calculation from area to circumference. And it's rendering it in a formatted text. If you ever want to go back to edit again, you just have to double click it. So let's save and export this entire notebook. To do that, we'll hit Control S, or you can also click on Save right here. And that updates our checkpoint to a second ago. And that writes everything back to the file. This is how you can send someone a notebook and they'll see your results without running anything. Now, sometimes you want to hand this to someone who doesn't use Python at all. For that, you'll have to export it. So go up to File and then Save and Export Notebook As. There are several formats here. The one I'd like to point you to is the HTML. It produces a self-contained web page and it works without anything installed, and it opens in any browser. And that's the whole notebook as a clean web page. So it has the text, it has the plot, it has the code. No Python is needed to view this. If you specifically need a PDF, there are two options. There's a PDF choice in the same drop-down menu, Save and Export Notebook As, and you can click PDF right here. But this needs an extra typesetting system installed behind the scenes, and it'll throw an error if you don't have it. The reliable route is to do the one we just did, so export to HTML. So we can open the HTML file that we just got. Use the browser's own print setting to export. So we'll do Control P, and then I can save as PDF and then save it in my project folder. You can open and see what that PDF looks like by going into our files, going into Python, and then circle demo PDF, and here you go. If you'd rather export straight to PDF, that needs LaTeX installed separately. You can find the link to the installation page in the description. It's a fairly big install, so the recommended route is still to export through HTML like we just did. So the last thing for this video is safely shutting down the notebook. Remember that terminal window we left running? Closing the browser tab doesn't stop Jupyter. The engine is still going to be running in the background. So to safely shut it down, you go into File, hit Shut Down, and then Confirm. And then now if we look at the prompt, it says kernel shut down, and it shut down everything safely. And that means it's properly stopped. If you ever just close the tab and walk away, it'll still keep running the kernel until you close that terminal. Now that you've seen both Spyder and Jupyter Notebook, which one do you use? So roughly reach for Spyder whenever you're building a program, something you'll run start to finish over and over with the variable explorer and debugger to lean on. Reach for Jupyter when you're exploring, working step by step and producing something you want to explain. It's like an analysis, a report, or a walkthrough. Plenty of people use both, and you don't have to pick a side today. Just know that they're both better at different things. So let's do a recap of what we looked at today. We launched Jupyter from the command line, opened a notebook, saw how code cells and text cells differ, ran cells and watched output appear in line, restarted the kernel to run everything cleanly, edited a cell and reran it, added our own text cell, and exported the whole thing to share. In the next video, we will finally start writing Python ourselves. We'll start with variables, the different types of data that you'll work with, and the pieces these programs have been quietly using all along.